angles in degree measure. Now, there is a secondary way in which we can measure angles that we study in math, and that is radian measure. The radian measure is an alternative way to express the size of an angle. Using radians allows you to express the measure of an angle as a real number without units. The central angle formed by one complete revolution of the circle is 360 degrees, or 2 pi in radian measure. Okay, so the circumference of a circle is found by taking 2 pi times the radius. And if we make the radius 1, it's 2 pi units around the circle. The distance around the circle in degrees is 360 degrees. Now, what we tend to do is change the ratio. Rather than using 2 pi, make it this. 1 pi radian is equivalent to 180 degrees. So if you are needing to find out what the measure of an angle is in radians or in degrees, you use the following to help you change it. So pi rads is 180 degrees. And if you're changing it 2 degrees, I go 180 degrees over pi radians. Okay, so for today, all you're doing is adjusting the measure from either radians to degrees or degrees to radians. Now, why? What's the point? Well, like the last 3 units we've been doing, good morning. Last 3 units we've been doing the regression graphs. Well, in order to do the regression graph for trigonometry, it can only be done in radian mode on your calculator. So we actually have to adjust the calculator and change it to radian mode. Okay? So we'll get to that once we get into the regression graphs. So first thing, estimate the value of 120 degrees in radian measure. So to convert. Now, the other thing that we are going to do, so to convert to radian measure, I times it by pi and divide by 180 degrees. Like that. Now, rather than multiplying by pi and getting a decimal answer, I mean, it's possible you can do that to get it in radians. I'm going to just leave it in fraction form with the pi value. So 12 over 18 is the same as 2/3. So this is 2 pi over 3. 120 divided by 180. 60 goes into both. So it works out to 2 pi over 3 radians. Okay? Let's do 220 degrees now. We get the units. So that's 22 over 18, which is 11 pi over 9. Now, by leaving it as pi, I'm leaving it as an exact value. Okay, I'm not converting it to decimals. However, radians actually can come in decimal form. So what we want to do is it says here, determine which angle is larger, 4 pi or 11 radians. Now, if it's given as a value with no degree symbol, it's assumed to be radian measure. So if there's no degrees there, it's radians. Okay, so it says 4 pi or 11. That means that it's 11 radians. Now, before I go much further than this, let's look at the circle again. Let's start right here. And let's go around the circle. How many degrees is once around the circle? 360 degrees. And how many radians is that? 2 pi. So if I go a second time around the circle, how many radians is it? 4 pi. So without doing the without doing the multiplying by the ratio, 4 pi radians is how many degrees? Right. Exactly correct. 720 degrees. Now, let's look at this as an approximation now. Let's change, and all I'm going to do right now, what I'm trying to do is I'm trying to show you which angle is bigger, 4 pi or 11, without multiplying by the ratio. But I will show you with the ratio. But let's look at this in terms of an approximation. Approximately, what is the value of 2 pi? Yeah, we'll go a little bit more, approximately 6.28, right? 3.14 times 2. So 6-ish works for me, okay? So now let's go one more time around the circle. So how many radians is it one more time around the circle? 12.56 radians, correct? All right, so 4 pi was 2 full turns around the circle, correct? If I go twice around the circle, I hit 12.56 radians. Does 11 go all the way around the circle twice? No, it stops short. So which angle then is larger? 11 radians or 4 pi radians? 4 pi radians. Now, let's think about this in a different light yet again. 4 times pi approximately is 12.56, right? So is 12.56 larger than 11? Yes. Now, let's find out what this is actually. So to do that, I'm going to take 180 degrees and I'm going to divide by pi. So on your calculator right now, take 11 times 180 and divide it by pi. How many degrees is it?
That's 632.4.
And 4 pi was how many radian or how many degrees? 720. Okay? So today you're just converting from radians to degrees and degrees to radians. It's that simple. All right, now I'm going to get into the graphing part again. Like I want to see if we can push this through a little bit. There's only 4, so we're going to do the second and the third one today as well, just to look at it. All right, what I want you to do right now, let's okay. I'm trying to think. Do we want decimals or do we want the calculator? Let's go calculator. All right, so take out your graphing calculator. I'm going to talk you through this right now, so I need you to go through this. I want you to hit y equals. I want you to clear whatever's in your y1. Yeah, clear it too. Then I want you to go to the top and make sure the stat plot is not on. No stat plot, please.
No, underline.
Pardon me?
Not underlined, you mean?
Right.
How do you do that?
Just go up to it and hit enter.
Oh. Okay.
Okay? Everybody's good so far? Now what I want you to do is I want you to type in y equals sine x. Close the bracket and hit enter.
Where?
Sine.
Oh,
The
on
X
Y1.
is by the alpha button. In y1, sine x. Can everybody just put that in, please? What's the problem?
I don't know if I have the right next to you.
Dang.
Is that-
That's fine.
That's-
You can do it that way. But that's your x right there.
Oh, okay.
That's why it has the theta on there as well. Okay, everybody's hit sine x. Now, all right. Next thing I need you to do, so I hope you're all following. Everybody's got sine x in there? Okay. Go to your mode right now and change it to radians. So hit mode and change it to radian, please.
How do you actually change it? Do you just hit enter on it?
Yeah. Got it?
No, not really.
Just press enter and it'll blink. Blink, blink, blink.
Okay. All right. Now what I want you to do, go zoom 7. Zoom trig.
Whoa.
Now we should see, in yours in particular, if you've done this the same way I've done it, looks like 2 complete wavelengths. Yes? Is that what you're seeing? Okay, now, there are parts to this that we have to understand. Okay? So the first thing, your maximum and your minimum is 1 and -1. Now, thinking about trigonometry for a second, and then I'll explain this using the unit circle. Because we did this in grade 11, so we're going to do it again. But thinking about trigonometry, when you are doing right angle trig, can sine and cos ever be larger than 1? No. Can sine and cos be less than -1? No. All right? So let's say that my radius on this circle, let's say my radius on this circle is 1. So the distance from the middle of from the origin to the outer edge of the circle is 1. What does that make this coordinate right here? 1 and 0. This coordinate right here, here, and down here, 2. Okay, now, again, it's going to take a bit of time this morning, but I'm going to show you this so that we get as good an understanding as we possibly can. All right, on this circle, we know that that distance is 1 right there. Okay? This coordinate here is xy. I don't know what the coordinate is. It represents all the coordinates on that line. Well, it also happens to be a coordinate on the unit circle. All right? With that in mind, this distance from here to here is x, and the distance from this axis to here is y. Right? That's xy. I'm going to make this angle right here theta. Everybody following me so far? So all I did was draw a triangle. I drew a line from the origin connecting to the unit circle. The point, the coordinate is xy. The angle is theta. I don't know what the angle is. It represents any angle. Theta doesn't, it just represents an angle. Just the same way that x and y represents a coordinate. Theta just represents any angle on this circle. So to find the sine of the angle in this triangle, what is sine? Opposite over hypotenuse. What is the opposite side to the angle?
Opposite of the 90?
No, right here, the theta. It's y over the hypotenuse, which is 1. What's the cos of the angle? Adjacent over hypotenuse. What's adjacent to the theta? X over 1. So what this tells us then, is that if I choose a coordinate anywhere on this unit circle, anywhere on this unit circle, the x value is going to represent the cos of theta, and the y value is going to represent the sine of theta. Now, why is this important to us? This helps us with the graph itself. And I want you to see what happens here now. All right. Utilizing this graph and that unit circle. The x-axis is going to be the measure of the angles in radians. Okay, so the x-axis is going to be the measure of the angle in radians. To begin with, I start right here. Along that axis, that is 0 degrees. So again, this is the measure in radians. So I'm going to go 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So I want you to write that down. You two guys need to stop snickering at each other because you're going to get left behind real quick. Okay. So, looking at this unit circle right here, 0 degrees is right here. What is the y value at 0 degrees? 0. That is this point right here. Okay. At 90 degrees, what is the y value? 1. Right here. So this is 90. This is 0 degrees. This is 180 degrees right here. At 180 degrees, what is your y value? 0. At 270 degrees, what is your y value? -1. At 360 degrees, what is your y value? Back to 0. This is what we call a periodic function. A periodic function is a function that repeats itself. So what's essentially happening here is this wave keeps going forever, and it just keeps going around this circle. So those coordinates stay the same as you go around. So if I look at putting in, what is the next one? It would be 450. So that's once around the circle, back up to here. Well, if I follow this pattern, what it should be? It would be 1. Okay? So this is a periodic function. Now, first thing that we need to know, period. What is the period of this function? The period is how long does it take for this to repeat? Now, I did mess this up a little bit. I shouldn't have done it in degrees, but whatever. We did it. What is the period of this function? How long does it take for the sine graph to repeat itself? 360 degrees. So if you want to find the period of a function, you take 360 degrees divided by b. So write that down. I'm going to have to make sense of that for you in a minute. So the period in this case is 360 degrees. How many radians is that? What is it? 2 pi radians. 2 pi radians. So we can either find the period by taking 360 over b or 2 pi over b. Like I said, I'll explain that in a minute. But the first thing we have to know is the period. The amplitude. The amplitude. Again, another new word for you. The amplitude is the distance from the equilibrium or rest position, as I call it. The distance from the equilibrium position. That is from here to here. What is the amplitude in this? 1. Distance is 1. So we need to know the period and the amplitude. The x-intercepts. There are an unlimited amount of x-intercepts. Because this function goes forever left and forever right, the x-intercepts occur all the time at when y is equal to 0. So give me 3 x-intercepts for this guy, for the sine graph right now. 0, 180, 360.
720.
720 is another one. Okay, wherever the graph crosses the x-axis is your x-intercept. And you can see that it happens in multiple places. I'll get to the coast graph in a minute. The domain of this graph. X is an element of all real numbers. X is an element of all reals. The range. What is the range of this graph? Yes. The range is -1, less than or equal to y, less than or equal to 1.
Must be because theta.
Okay, so you can see that the y value goes as low as -1 and as high as +1.
Does the domain not stop at,
No. Those are arrowheads on the end of it. It goes left forever and right forever. Periodic function does not stop. We have an amplitude of 1. I talked about that. The period is 360 or 2 pi. The midline. The midline is the equilibrium line that essentially divides it in half. It's an equation of a line. You can find it by taking the halfway point between your max and your min. So if you add your minimum to your maximum and divide by 2, you'll get your midline. In this case, it's 1 plus -1, which is 0 divided by 2. Your midline for this graph is y equals 0. Okay. Now, the coast graph. Difference is the starting point. At 0 degrees, what is the coast value? 1. It's now we're looking at all the x values as we go around the circle. So the coast starts right here. At 90 degrees, what is the coast value? 0. At 180, -1, 270, 0, 360, 1. The coast graph looks like this. And it goes forever as well. The coast is the x value of that graph.
what's the point of graphing all of this?
Trigonometric graphs. Much like all the other graphs with regressions. So tides work with periodic because they all come back to the same levels daily. So we're gonna look at tides. We're gonna look at Ferris wheels. Okay, where you create the equation because they work like the unit circle. So there's a couple of different. So exponential, you didn't ask that question for exponential. Earthquake measurements are all done on the Richter scale, are all done by exponential. All right. So those are some of the things that we apply the math to. Okay. All right. Emily says this is a graph of y equals sine x. Is she correct? Is that y equals sine x?
For the coast graph, what are all the points? Like,
The x values are the same.
Yeah.
So if I you know what, I could do it like this. So I'm following the x values around this circle here. So it starts at 1, 0, -1, 0, 1, like that. Okay? And then 450 would be 0 again. All right. The x values, we didn't talk about that. Your x-intercepts, where do the x-intercepts occur? Give me a couple examples of x-intercepts for the coast graph. 90 and 270. Okay. All right. Okay, now. All right, let's leave that. Tomorrow I will go through the equation of a trig function and the sinusoidal regression. No, I'm just going to go through the equations tomorrow. Wednesday we'll do the sinusoidal regression and then we're done. Okay, so tomorrow will be equations of a sinusoidal graph. So that's the sine and cos graph. And then Wednesday we do the regression graphs and we're done with what we need to get done before Christmas, which is ideal.